So, good afternoon, everyone. I welcome all the course coordinators and all the course participants from various institutes which are connected to the EduSat Center at IIRS in this outreach program. So, today we are beginning the new module and new course on the Global Navigation Satellite System, wherein we are going to discuss the satellite navigation. I am Dr. Ashutosh Bhardwaj, Head of Research Project Monitoring Department at IIRS. So, in this module, we are going to have 2 weeks of lectures, which will be consisting of the satellite navigation part 1, that is today. Thereafter, it will be followed by another satellite navigation lecture part 2, because now this subject has become very important and new applications are coming up, so we need to delve some more time to it. Thereafter, we will cover the GPS receivers, processing methods, errors and accuracy. After that, on 29th, we will have the lecture on the Gagan, our own satellite based augmentation system. Thereafter, we will discuss the GPS signal characteristics, data formats, followed by Indian Regional Navigation Satellite System, that is the NAVIC of India. Then we will have a recorded demonstration on the differential GPS survey, followed by the advanced GNSS processing. So primarily, what we are going to do in this course is that we will be learning about the surveying techniques using the global navigation satellite system, which can further be used for the mapping purpose, that is for the cartographic purpose. So here, as a part of the history of mapping and surveying, I would like to start with the basic requirement of mapping from time immemorial. So from the very beginning time, prehistoric times, the human beings have a requirement of origin and destination. Basically, they have to travel from one place to another place, and they have to return to the starting place also, because it is a social being. So family is there, so you may be moving to another place based on some method or idea. So at the beginning, it was the use of mental maps. Basically, the human beings, they are very good and smart in noticing their surroundings and the celestial bodies. So in the daytime, they can use the sun for the direction, and in the night time, various stars and planets and moon for the purpose of the navigation in the night time. So like that, these mental maps has been used. Besides that, some markings has been used on the trees or the hillocks, caves, which has been used for the purpose of the navigation. So that is one thing. And thereafter, in the modern times, when we have unearthed various civilizations during the archaeological surveys of Indus Valley civilization, Babylonians, Egyptians, Greeks, Romans, and many others, it has been seen that their settlements are very well planned. They have perfect perpendicular roads, or as per their desire at that times, because that is visible from the logic when we are going through those kind of settlements. They have very good drainage systems, they have ventilation systems. So that means they have been aware of the nature, and they have been using it for the purpose of creation of a comfortable environment around them. Maybe the modern names of the subjects were not there, but those logics has been the science of those days. And in this, the surveying is one of the very important subject as we understand today. So in the surveying, we have been studying in various disciplines like the civil engineering, geology, geographers, agriculture people also do survey, forest people also do survey. So they have been using different type of chains, tapes, cross staff, optical square, theodolites, tachymeters, compass, levels, electronic distance measurement devices, total station. So up to here you have seen many type of surveys which are going on when you are traveling on the roads. People are standing with the EDMs, the surveyors, and another person is also standing either with a staff to take the reading or with a reflector. Reading will be taken at the end of the equipment. Okay, however, here what was the issue that in these all cases there was a requirement of a clear line of sight. So if anything comes between the equipment and the staff or the reflector, we are not able to take the measurement. So that was one limitation in all these equipments. However, thereafter the development of global positioning system took place, what we call today as the global navigation satellite system, with the development of various constellations of satellites developed by various countries that we will be discussing. So in this system, in the GPS or the GNSS, this clear line of sight requirement is not there. So we can survey at different far places without being intervisible to each other. That is one advantage which GPS has and which makes it different from all other surveying equipments which we have been using so far. And these surveying equipments, we have been using the classical methods of triangulation and trilateration. So we have been doing the open traverse, closed traverse from one part of the country to another part of the country, or depending upon the small or large area which is required to be surveyed. It can be as small as your house. So for that also requires a survey wherein we require to demarcate the boundary of the land, and we need to have the arbitrary datum for the vertical height. From there to the global applications where we have geodetic coordinate system where we have origin at the center of the earth. So from an arbitrary datum to such a geodetic system or geocentric system we have been using, wherein the triangulation and trilateration has been the key method to do the survey. In triangulation, basically we have been using the angles and the length of the sides of the triangle, that is the baselines in terms of surveying, that is the distance between the two referred points. Whereas trilateration is a special case of triangulation where we are not measuring the angles, all the measurements are done based on the lengths. So these methods have developed in the 19th and 20th century and we are continuing with them. The change came with the launch of the Sputnik 1 satellite, which was launched in October 1957, followed by Sputnik 2 in November 57, and these two has been launched by Russia, whereas the Explorer series has been launched from January 1958 onwards by USA. So these satellites, when we have launched, the challenge was that to locate the satellite where it is and is it in the correct orbital path, or we have to do the some kind of maneuvering to maintain the orbit of the satellite. In the meantime, what has happened that when we have been learning about the satellites, we started learning about the earth as well. So it is a, we can say, a feedback mechanism is there. So we were trying to model the orbital paths, and in that exercise we also learned to define the earth's shape in a better way. So because of the development of the satellite science, what has happened that we are able to derive new earth flattening ratios, and that was 1 by 298.3 in 1958. Thereafter, for various measurements, simple satellites like LEGOS, that is the laser geodynamic satellite, or the laser geometric environmental observation satellite, were launched by USA for again the orbital modeling, and similar satellites Etlon was launched by Soviet Union, which was also for the mathematical computations of the orbits or the orbital dynamics, we can say, along with the gravity measurements, magnetic measurements, geodynamic measurements. So these activities started in the 1970s itself, we can say, and currently the GGOS geodetic organization that is trying to do various type of surveying through an integrated system using the laser ranging, satellite laser ranging, VLBI, very long baseline interferometry, GPS, DORIS, and various techniques which are developed from the satellite sciences. So there is a learning backward also, as I told. We have been trying to learn about the orbital dynamics, and we started learning about the shape of the earth, and we are getting better and better shape of the earth thereafter. So we got geode 90 for NAD 83 datum in 1990. Newer techniques with the advent of fast computers applying good mathematical tools for the error adjustment such as least square ambiguity decorrelation adjustment. These better techniques for the error adjustment resulted in a better measurements. That means it has less of the errors. Now with this we can see that a lot of interfaces happening between different type of technologies and between the way we have been working on the ground and the way we have developed the satellites. In this entire exercise, what has happened that we as scientists or the technocrats or working in the various disciplines of sciences such as agriculture, forestry, or various disciplines of engineering like electronics engineer, however working with the synthetic aperture radar and so on. So it became a very much essential for the people like us that we require some understanding of surveying, some understanding of physics, along with some understanding of geodesy, statistics, astronomy, electronics to continue in this multidisciplinary field of remote sensing basically. So all these are required in case of the GNSS also, Global Navigation Satellite System. Now as I have told that it is a continuation of the development of the surveying equipments, so maybe a bit of time we can give to the surveying also. One of the basic definition of surveying is like this, that it is a science and art of determining the relative positions of various points above, on or below the surface of the earth. So earlier we were limited to the earth, so this was okay, but later we have gone for the extraterrestrial space and now we are doing surveying using the geometrical and trigonometric formulas beyond the earth also. So now we have Google Earth, we can see the maps of the moon and the maps of the on the Mars also on the Google Earth. I hope you have explored that sometime or you can explore. So on the Google Earth not only you get option to go through the earth, whereas you can explore the sky, you can explore the maps of the moon, and you can explore the maps of the Mars. All these four options are available on the Google Earth. The main purpose of surveying, however, is still for location determination and preparation of a map. So that means a cartographic output is mostly essential at the end of the surveying exercise. Maybe it may be used for revenue purpose or some tax collection or some construction activity. However, we are having some end product in the terms of the maps usually. So as we were talking about the way we have been learning through the celestial measurements for the navigation purpose, for the landmark based measurements, various devices has also been developed in this time. So such as the magnetic compass, gyro compass, radio direction finding has been developed, radar and inertial navigation has been developed. So these were some of the very quick developments related to radar which happened during the World War I, World War II. So quick developments took place that time because of the Cold War era between Russia, US, and faster rate of development was there. And besides that, there was tower-based navigation systems also which were developed, like the long-range navigation, that is LORAN A, LORAN B, which used very low frequency radio-based systems. LORAN C was also developed, which was using high frequency radio based systems. So Lawrence was developed by the USA, whereas Chaika system was developed by the Russia. So these two systems has been in use for the purpose of navigation over the Earth in their region of interests. Now these systems were regional in nature, as I am trying to explain. However, we should also know that in the due course, USA developed the Omega system, which is also a terrestrial tower-based system, and Alpha was developed by Russia, which is again a terrestrial and tower-based system. These both systems has been the first global navigation terrestrial-based systems. So before the satellite-based navigation systems, which are global in nature currently, we do have similar systems based on the terrestrial. So on the surface of Earth also we have towers which provide similar things, similar computation, however with a lower accuracy. So as we can see here, the Lawrence has been providing an accuracy of 180 meters. The initial satellite based system has been providing through the transit system 200 meters of accuracy. Tactical air navigation was providing about 400 meter accuracy, whereas the inertial navigation systems has been providing 1 kilometer accuracy. Omega system was providing 2 kilometer accuracy. Now currently what we are getting is the GPS. From a standalone GPS we are getting accuracy of the order of 10 to 20 meters. If we are using a latest GPS, then of the order of 3 to 5 meters also. So that kind of development has took place, and there is a continuous development which is taking place. So now the point which we want to make here is that there is a terrestrial based system which exists for the movement across the Earth, that is the Omega and Alpha, and there is a satellite based system also which exists, which we know as global positioning system, which was first satellite for which was launched in 1978, and its initial operational capability was announced in 1993. Final operational capability was announced in 1995. Now before the development of GPS, regional satellite based navigation system was developed by US, that is called the Transit, and a similar system was developed by Russia also, which was called Cyclone. So these also were part of the development. So you can see here that Lawrence and Chaika, they were regional terrestrial based systems for navigation. Transit and Cyclone, they are again regional systems developed by US and Russia. Thereafter followed by Omega Alpha, they are global systems, terrestrial based, analogous to global systems, satellite based, GPS and GLONASS. Okay, GPS is by USA, GLONASS was by Soviet Union, erstwhile Soviet Union, and currently Russia. So here the GPS and GLONASS, they both got IOC in 1993 and their FOC, final operational capability, in 1995. Now the service providers, international GPS service, it began in 1994. Before it was called International Geodesy Service. Currently it is called International GNSS Service. So that also you can see the naming has developed as per the technological changes. So names has also been changes or updated as per the technologies which are coming in. In the earlier days, when there was a bit of competition in the US and Russia, and we had a Cold War era, that time we used to have separate receivers for the GPS, separate receiver for the GLONASS. However, after the perestroika and the consecutive incidents and better episodes, there was a good relation between the US and Russia, resulting in the conceptualization of the global navigation satellite system. This concept was made on the basis of the availability of the codes and details to the vendors, so that they can make a single receiver which is capable of providing a solution using combined use of GPS and GLONASS. The GLONASS and GPS both are available in a single system. That was the basic definition provided to the GNSS, that when we are using multiple positioning system, satellite based positioning system, in a single receiver, that is the GNSS. So that time GPS and GLONASS 2 were only available. However, today we have a updated language definition of GNSS, which we will also see in the coming part of the lecture. Now thereafter the tower based systems has also been enhanced. So enhanced LORAN, that is long range navigation system, has been developed. Similarly eChika by Russia, so it has been providing an accuracy of the order of 20 meters or so. So GPS is providing standalone accuracy of 10 to 20 meters. LORAN tower based systems also provide accuracy of the order of 20 meter. So after the disintegration of Soviet Union and formation of Russia, there was some dull time for GLONASS when it was not fully functional. Partly it was functioning. However, full functionality has again been resumed from 2010 onward. And in 2010, the quasi-Zenith satellite system was also developed by the Japanese. So they started developing their own regional satellite-based navigation system. Okay, so we have to understand that there was a development of regional terrestrial based navigation systems, there was a development of global terrestrial based navigation system analogous to the regional satellite based navigation systems and the global satellite based navigation system. So both the things are moving. And in 2010 there is a concept which came in for the integrated receivers, wherein the satellite based navigation systems and the ground based or the terrestrial based tower based navigation systems were combined into one. So we have a GNSS plus enhanced LORAN plus enhanced SACA. So we have a combined receiver for the satellite and terrestrial based technologies. So this was a solution combined which is coming from the two technologies. India also developed its Indian regional navigation satellite system in the period 2013 to 2016. It has also been approved for all the standards and the protocols used for mobile telephony or standalone satellite based navigation system in the Indian region and 1500 km beyond the Indian region. So that is the footprint for the IRSS, wherein we can use the IRSS. Then in 2022, BDO, which is the third global navigation satellite system, we can say, it also completed by the end of 2019. However, some spare satellites were to be launched in 2020, which were launched. So full operational capability, we say, for BDO was achieved in 2020. However, it was fully operational in 2019 itself. So this Electronica is one of the company which provide a combined chip, and it provide a enhanced differential LORAN service also, which is also solar powered. Okay, so this is a small chip, 6 centimeter by 2 centimeter, and this is capable of providing a combined solution for the satellite based positioning as well as the terrestrial based positioning. Now when we are talking about the satellite technology, so there are different technologies. So one is the topic of today, that is the global navigation satellite system, which we are learning. Then there is a satellite based laser ranging, which is based on the retro reflectors. So we are sending the laser pulses and computing the time, and based on that we are solving for the satellite orbits. Similarly, very long baseline interferometry is being used, which primarily use the distant sources of the radio signals. That is one technology, VLBI, wherein about 20 countries are involved and 40 organizations are there, which has installed 45 antennas. So this is maintained by the International VLBI Service for Geodesy and Astronomy. So this provides accuracy of the order of few millimeters in position for the antennas, which are spread over the earth, and they are few thousand kilometers away from each other. The baselines are quite long. So this is another technology which is being used for the we can say for the surveying, for the geodesy, for the satellite based surveying navigation. So this GNSS, SLR, VLBI, then DORIS is there, Doppler orbitography for and radio positioning for integrated used by the satellites. So Doris is by France. That is also a system developed based on the measurement of the Doppler shift. SAR interferometry can also be used for the purpose of mapping the ground, creation of digital elevation models, for the computation of the deformation in the ground, and then satellite altimetry also. So we have ISAT 1, ISAT 2, TOPEX, positive, and many satellites are there which are also contributing to the parameters which are required for determination of the shape of the earth. So that is the way these all six technologies. So INSAR and altimetry you will cover in the application part, somewhere it will be covered in the lectures. Now, these are the two books which I am prescribing for you, because they are free ebooks you can download. One from the Novotel site. You have to just enter your email ID and they will provide you the link to download this book, which is the third edition, and the title is An Introduction to GNSS. Then another is the GPS, the first GNSS, that is by the free ebook by the Trimble. So these two books you can use. There will be other books also available. However, I will suggest you these two. So Doris is again computing the distance between the ground stations spread over the earth for the Doris network and the satellites. So this is also using the radio signals for the Doppler measurements at 2 gigahertz and 400 megahertz. So what it is doing, that when the ground station is there, so and the satellite is moving in its orbit, so it has a larger distance here and it is coming near to the ground station. So there is a change in the frequency of the signal, and then again it is moving away from that. So this change in the frequency is computed, and that is used for the location of the nearest position of the satellite from the station, ground station. So that is one way of computing the satellite orbits. So here again we can see that we will find in the entire discussion that timing is a very important part. So we are looking for picosecond kind of accuracies or better than that. So 1 in 10 to the power 12, 1 into 10 to the power 13, or 1 in 10 to the power 14. That kind of timing accuracies we require for the computation, because we are dealing with the electromagnetic radiation which is traveling at a speed of 3 into 10 to the power 8 meter per second. So smaller deviations in the time can result in larger errors in the computation of the distances. Then the satellite laser ranging is another technique which use the ultra short pulse lasers to compute the round trip time of flight from the ground stations. So the satellites are having the retroreflectors in them. So Indian Regional Navigation Satellite System, they also have the retroreflectors in them. So they are helpful in computation of the distance of the satellite from the earth and helps us in the orbital dynamics. There are some laser ranging centers which are equipped for measurement of the lunar laser ranging also. So some of the stations have that capability, and they can do the measurements from the retroreflectors available on the moon also. This technique is also capable of providing millimeter level precision that can be aggregated over the global network to provide very accurate satellite orbits, and it has the capability to provide the time histories of station position and motion also through continuous measurements, and can provide many other geophysical parameters like earth orientation parameters, the geocenter of the earth. So that also can be computed using these SLR techniques and the VLBI techniques. So normally in this we are using the 532 nanometer, that is 0.5 micrometer, which falls in the optical range. So in SLR we are using the optical range, and it's usually used for measurements from 300 kilometer to geosynchronous. However, as I told, some of them are capable of doing measurements up to the moon through the lunar laser ranging. Now the earlier SLRs were dependent on the ultra short pulse lasers. However, new ones are working in the kilohertz region using the new technology of the photon counting. So that is the change which is happening, and the NASA next generation satellite laser ranging system will be based on this new technology of the photon counting. Now, in a recent study, it has been seen through the Sentinel 3A and Sentinel 3B mission that this mission is equipped with GPS, DORAs, and then the satellite laser ranging equipments also. So we can see here that these studies show a consistency of estimated satellite coordinates better than 13 millimeters. So that kind of accuracy, like, so 1.3 centimeter accuracy is coming for the satellite, and geocenter coordinates with the root mean square error, center of the earth coordinate with the 6 millimeter of the RMSE, pole coordinates with the RMSE of 0.19 milli arc second, and the length of the day can also be measured with the RMSE of 0.07 millisecond per day when referred to the IERS, Inertial Earth Rotation Service, International Earth Rotation Service, which maintain the ITRF coordinate system. So this is from the study by Strugark et al. 2019. So that kind of developments are taking place beginning from 1976 when the first laser instrument was launched for this purpose, and to the latest Sentinel 3A 3B mission. So we are talking about some millimeters of observations. That kind of observation accuracies are there, and these are very useful for the crustal deformation. So now this was a exposure to the various satellite based surveying techniques. Now we will continue with the details of the satellite navigation, and we'll focus more on the global positioning system, Navistar, GPS, GLONASS, BEDO, and Galileo. These four are the standalone satellite navigation systems which are working globally, and they have a full autonomous geospatial positioning service. What we call standard services are available for the civilian purpose, and the restricted or the precise services are available for the defense purpose of various countries which have evolved these systems. Then thereafter we have the regional satellite navigation systems also. IRSS belonging to India, that is NAVIC, and the QZSS quasi-zenith satellite system for the Japan. So initially the GPS, Navistar GPS, it was developed as a military system. It is a 6 orbit based system. When we see from a particular look direction, then we can see that this appears like 3, but this is the overlap of the satellite orbits actually. So primarily 6 orbits are used, where in each orbit we have minimum 4 satellites, making it a set of 24 satellites. Initially it was developed for the defense purpose only. However, the accident of Korean Airlines in 1983 made President Ronald Reagan to announce that this particular global positioning system will be available for the civilian purpose also, looking at its capabilities and the civilian usage importance also. So that was happened because of this one of the major accidents which took life of 269 people. So now this is a system for enhanced LORAN, like our today's BSNL towers, you can say, wherein also we can locate the position of a mobile using the trilateration method. So or we can do the triangulation for the mobile. So similarly we are doing triangulation or the trilateration for the GNSS receivers or the receivers of the LORAN or the Chaika series or the Omega. Okay, these are the different ground based systems and the satellite based systems. These are the footprints for the LORAN coverage, and this is the availability of the US system for LORAN. Different towers are there, and this is the integration of the satellite based systems with the tower based system. what we talked about, the chip by the Electronica, wherein a single chip is providing us the solution based on the tower based system, that is terrestrial system, as well as the satellite based system, that is the space based system. Okay. So in Xiaomi Mi 8, this was launched in market around 2017-18 period, and it was one of the smartphones which came with the dual frequency receiver. So if we have a GIS facility in the our PDA, Pocket Digital Assistant, or the mobile, then we can compute the position within the mobile also directly using a software. So that kind of change came in the market with the launch of the smartphones. Some of the mobile phones in 1999-2000 period were also available by Maglin for the purpose of the positioning. However, this is a smartphone which came around 2018. Then now we have a facility for Navik also in the mobiles, and as you have seen, the recently we have from the Apple also, in the Apple 15 latest model, we have the availability of Navik signals. So in the Europe, there is a service called Eurofix which is available, and they provide the integrated solution through the Navistar GPS with Lawrence C, that is the terrestrial based systems. Okay, so these kind of services are also there which use both Lawrence C and Chaika along with the GPS and GLONASS. So this is called the Eurofix service, which is available in the Europe. In India also, the developments has taken place for miniaturization of the chip, which was a challenge earlier. However, it has been resolved, and now we have a smaller chip. One such chip was developed in by the IIT Bombay team also. Now different handsets are coming with the mobile apps. One of them is developed by the MapMyIndia, because now they are partner to the government of India in providing the mapping solutions. So MapMyIndia has a solution for Navik in the mobiles. So you can use this for building of different apps. Now in the Apple iPhone also, from 15 model, we have the Navik signal available. So there is a lot of change which is coming in the handsets or the smartphones, and we will see that in the times to come we will have a large number of handsets. So currently we have Xiaomi i11X, 11T Pro, OnePlus Nord 2T, and Realme 9 Pro. So these are some of the handsets which are having the facility of the Navik. So that kind of technological development is taking place from very simple systems to the Android based systems which has developed. Now how this idea has developed actually, that when the Sputnik was launched in 1957, so Doppler shift technique was used for computation of the position of the Sputnik in the orbit. Now at that time, the head of the Applied Physics Laboratory, the Mr. Frank McLure, he has given a task to his team that whether the inversion of that is possible. What is the inversion of that? See, inversion is that when we are talking about the Sputnik, the problem is like this, that we know our position on the Earth. However, the satellite position is not known in the space. Inversion of it means we know the position of the satellite in the space, however the position on the ground is not known. So that was the idea with which the first satellite based system transit was developed in late 1950s. It was a set of 6 satellites which were used at a time, because a large number of satellites were mobilized for this purpose also. So we were using 6 satellites at a time at an altitude of 1100 km with a revolution period of 108 minutes. So transit systems were providing the positioning in a area specific region, and Cyclone was developed by Russia. So transit and Cyclone, they both were regional terrestrial based regional satellite based positioning systems. Cyclone was having 2 parts, one for the military that is called the Paras, which is having 6 satellites, and Cicada for the commercial purposes, that is having a 4 set of satellites. So that is how the beginning of satellite-based navigation system started with the transit and the cyclone. The limitation was that it takes time to resolve the position. So it took about 40 minutes of time and it provided 2D solution. So for the oceanic applications wherein they were worrying about the ships, warships or the submarines, there it was okay because the elevation can be considered as the mean sea level. And latitude, longitude we will solve through this. So this system, the transit system was operational till 31st December 1996. So it was having a overlap of 1 year or more with the GPS system. Okay, because GPS full operational capability was achieved in 1995, so transit was also kept working till 1996. So there were two different systems operating in different ways. Now this all has provided lot of data, and there was a learning backward also. So we were resolving the orbital dynamics, at the same time we were learning more and more about the Earth. So new publications came for the Earth models, which included the standard Earth model from the Smithsonian Astrophysical Observatory, SEO, SE1 to SEO, SE3, and similar model Goddard Earth models were also developed. Currently we are using Earth geoid models using the gravity measurements, and the different type of technologies all are combinedly used nowadays. So EGM 96 and EGM 2008 we are using, and you must be aware. So these backward learning has also happened, and we have grown up in terms of our learning about the Earth. Now in 1970s, so more than 50 years back, actually this all was happening. Science was developing in terms of the ground-based solutions, satellite-based solutions, and combined solutions. So that has resulted in the determination of connections between the different geodetic datums. And these conversions of different geodetic datums from one to another was having an accuracy of the order of plus minus 50 meter. So today it may be looking poor, but that time it was a quite big achievement. So currently we are talking about 1 to 3 meter accuracy when we are using the EGM 2008 model, or maybe around 7 to 10 meters accuracy when we are using EGM 96 model. So in this entire exercise, also the effort has started in 1976 on when the Legios satellites and the ET satellites from the Russia and the US were launched. So they were like this, aluminum coated brass plated spheres which has retroreflectors, and they have been launched for the purpose of the geodetic measurements, helping us in making the accurate satellite orbits. And now this you will be surprising to know that these particular satellites, the Lagos and the Etalon from US and Russia, they have a life period of few hundreds of years. Usually we have satellites because which have life of 10, 15, 20 years. But these satellites have life of hundreds of years because these are passive satellites. So as we discussed, transit and cyclone were developed and finally resulted in the GPS. So we have an official definition of GPS, which is as follows: that it is an all-weather space-based navigation system developed by the US Department of Defense to satisfy the requirements for the military forces to accurately determine their position, velocity, and time in a common reference system anywhere on or near the Earth on a continuous basis. So, very clearly it is understood that we are getting the latitude, longitude, and height from the satellite. Besides this, as per the requirement of those days, the other parameters required were the velocity, which is also an output of the GPS receivers, and the technology, and the time also. So the GPS is hosting the atomic clocks and is determining the time based on more than 200 atomic clocks actually through an ensembled computation. So GPS primarily act as a timing laboratory. Okay. And the way it is different from the all other surveying techniques is that we used to have local datums, national datums. However, this Navistar GPS, it works on a common reference system. That is the WGS84, which we are defining as the best fit curve to the shape of the earth. So that way it is much more accurate, much more usable, not only in one place, one district, one state, or one country, but across the globe. So that is the beauty of this technology, that it works in a similar fashion all over the globe. Now this has an advantage that this do not require clear line of sight, and as compared to the ground based systems where we have the attenuation in the radio signals. When the ground based tower based systems are working, the space based systems uh, are having a upper hand in that also, because it do not face that kind of challenge for the attenuation of the signal. However, in the urban canyon or canyon regions or tunnels, we may have a problem in the signals of satellite. Otherwise, on the whole, this is a much safer, much easily available, and much more accurate technology available for the surveying solutions globally, particularly for the study areas which are larger in size and goes beyond the countries. So wherein you have to make a road network, railway network across the countries. So there you will not have connectivity issue in the construction taking place in different countries, as they follow the same datum WGS84, and they use the same equipment. So same equipment for the GNSS you can use on one side of the border, on another side of the border. Those engineers will align themselves based on this technology. So that way this is very useful. Now coming to the GNSS, where initially I told that it is a technology where we are using constellation of constellations or system of systems. So that means we are using more than one system, like the GPS and the GLONASS. So if we are using two together, it is a GNSS. However, over the time, the technology has grown. We have incoming Galileo, we have BDO, we have IRNSS, we have QZSS, we have different systems which has come on the ground, and we have different systems which are there on the aircrafts. So when we combine all of these satellite constellations, aircraft receivers, system integrity monitoring, now this GNSS is considered as an umbrella term for them. So it is now a worldwide position and time determination system that includes one or more of satellite constellations, aircraft receivers, and system integrity monitoring. That is, it is maintaining the mathematical correctness of the solution, augmented as necessary to support a required navigation performance for the intended operation, because different operations are there based on the different applications. So somewhere you require meter level of accuracy, sub-meter level of accuracy, centimeter level of accuracy, or millimeter or sub-millimeter level of accuracy in the crystal deformation. Okay, so different type of applications are there. So accordingly, we have to use different type of GPS receivers, which you will come see in the coming lectures, and different type of processing methods will be there to provide the solution. So based on multiple usage of system for to understand as of now, when we are using a set of GNSS receivers, we develop a system called satellite based augmentation systems, which is useful for providing real time kinematic solutions, high accuracy, such as for takeoff and landing of aircrafts. So similar systems are developed all over the globe. We will have a dedicated lecture on this topic. So we will discuss it in detail then. So currently GNSS is a multi-model system which is working over the earth and beyond the earth. It is working up to the Lagrangian point between the moon and the earth. So it's quite a long few lakhs of kilometer from earth's surface this signal is available. So it has operational use in the ocean, on the land, and in the air, and in the space. All the satellites which we are launching nowadays, they are having the GNSS receivers. When we are launching our satellites, we are also putting IRNSS receivers on them. So these receivers not only help in positioning of the objects on the ground or in the air, but they also help in the positioning of the satellites in their respective orbits. So this is one of the technologies which is again useful for positioning of the satellites. We are having hundreds of uh, small satellites in the orbits now, besides the major ones. So the positioning is being done within an accuracy of the order of 10 centimeter. So that is happening with the combined solution of different technologies, and GPS is also on board there on the satellites. So now here we will talk about the advantages of the GNSS. We have talked about the GNSS a lot, that we have 6 orbit based Navistar GPS, wherein we are putting 24 satellites providing the latitude, longitude, and height. So with the GNSS, what has happened that we have combined use of GLONASS, GPS, Galileo, BEDO, IRNSS, QZSS. So what has happened that it provide increased availability of the satellites and signals. So even in the canyon region also our availability increase, and we are going to have visibility of large number of satellites, and that will provide a more accurate solution, which is known or measured by the dilution of precision. One parameter is there, analogous parameter to the root mean square error. We will discuss it in detail later. And this provide us a better atmospheric correction. So that is, there is a certain advantage when we are using more than one GNSS system. So when we are using GPS, GLONASS, Galileo, BEDO combined, we are in a better position. There is no recurring cost in it, and these systems are very robust. Real-time applications can be used, and they are less expensive relatively for high-end services, because we have to procure them once, and there is no recurring charges like in case of our mobiles. So there we have monthly bill. That kind of thing is not there in the GNSS receivers. So now we will see that what are the general characteristics of these systems, satellite based navigation systems, that is the GPS, GLONASS, Galileo. So they are having a position accuracy of the order of 10 to 20 meter. Then they can provide accuracy in velocity of the order of 10 centimeter per second, timing of the order of 15 nanoseconds to 20 nanosecond. So these kind of high accuracies are provided by these 4 global navigation satellite systems when operating standalone or when they are operating combinedly in the umbrella of the GNSS. Okay. So now Navistar GPS first satellite was launched in 1978, whereas the GLONASS development started in 1982 with the launch of Cosmos 1413. Then the GEO, that is the Galileo in-orbit validation element satellite, first was launched in 2005 for Galileo. However, Galileo constellation is yet to be announced fully available. It is partly functioning with good number of satellites. However, it is still to be fully mobilized. BEDO 1, 2, and 3. So BEDO 3 is nothing but the BEDO actually full. So BEDO has been developed as a scale up model, where BEDO 1 was providing service in the Chinese region somewhere around 2010 or so. Thereafter it was scaled up with more number of satellites and with a better footprint to BEDO 2, providing in the Chinese region and the South Asian region. And then the BEDO 3 completed the global coverage. So there is no need of 1 to 3 now. Basically, it's a BIDO now. So BIDO is also Global Navigation Satellite System, providing an accuracy of the order of 10 to 20 meter in position. It has certain issues with the atomic clock. So global accuracy is normally considered as 50 nanosecond, whereas their regional accuracy in the Chinese and neighboring region is considered as 20 nanosecond. All of them are having their own ellipsoid systems, but since all the space agencies of US, Russia, European Union, and the Chinese all are collaborating, so the transformation parameters are known. So WGS84 is used in the Navistar GPS, parameters MLA is used in the GLONASS, Galileo uses the GTRS system, that is the Galileo Terrestrial Reference Frame, whereas the Chinese Geodetic Coordinate System 2000 is used by the BIDO. So since transformation parameters are known, any of them can be selected by the users, which are there globally as per their requirements, and they can use it for the civilian or the military applications. So these systems are available for both of the purposes and are available to the general public as well for large number or a very new applications which are coming up for the social purposes. These all are used. So GPS is working as a 6-orbit based system as shown here. It is all the systems are dynamic systems. So satellites are moving in their orbits, Earth is revolving and rotating as well, and minimum 4 satellite signals are required for the positioning, because 3 parameters, that is the latitude, longitude, and height, they are the unknowns. So as per mathematics, simple rules are there. For computing n number of unknowns, we need n number of independent equations. So for 3 unknowns, latitude, longitude, height, we require 3 equations to be found with the 3 satellites. However, since the ground receivers, they have quartz clock, and the satellite receivers, they have the atomic clocks, so there is a discrepancy in the synchronization of the 2 clocks. So that is referred as the clock bias. So that also need to be resolved. So our unknowns become 4, x, y, z, and b. B represent the clock bias. So 4 unknowns means 4 equations we have to form. So 4 signals we need to get. So the Chinese system BIDO, it uses about 7 different satellite orbits in the geostationary orbit, inclined geostationary orbit, and the low Earth orbits also, medium Earth orbits. So bit complex design is there for the Chinese system, BIDO system, whereas GLONASS and Galileo, they are 3 orbit based systems. So they have 9 to 10 satellites in each orbit. Okay, so these 3 designs are there: 6 orbit based, 3 orbit based, and about 7 orbit based, which are used by these different systems. So the services provided by the GPS are the standard positioning service for the civilian purpose, precise positioning service for the authorized users or the defense users, standard precision service for the GLONASS, high precision service for the GLONASS, respectively for the civilian and the authorized users. Similar services, open service, safety of life, commercial service, and so on, they are used for the Galileo because they are using a commercial model. So police and anti-fraud agencies, there is a service. Search and rescue operation is a service. Whereas for BIDO also they have an open service and the authorized service. So these are different kind of services which are available, and different type of frequencies, bands which are used. We will see in detail in the following lectures. These satellites are moving with about nearly 4 km per second speed or velocity in their orbits. By the time the signal starts from the nearest position, like for the GPS, when the nearest position of the satellite to the receiver on the Earth is 20,180 km, when the signal starts from the receiver to the from the satellite to the receiver, In the time it reaches, it moves 260 meter in its orbit. From the farthest position to 25,820 kilometer, when the signal starts and reaches the ground, it takes about 86 millisecond, and it moves. The satellite moves about 333 meters in its orbit. So I hope you have understood. This is a simple computation of measuring distance, velocity for the movement of the satellites in their respective orbits. So similarly, it is shown for the GLONASS, Galileo, and BEDO systems also in the table. Importantly, what has happened that the inclination for GPS is kept as 55 degree for a better coverage for the areas of interest of US. Although the systems are global, but still they have some priorities. For the Russia GLONASS, they have put at 64.8 because they have a lot of interest in the northern polar regions where they have Siberia and other regions, so they have put a more inclined orbit. Galileo satellites are at an orbit of 56 degree. For BEDO, some are in the geostationary orbit, some are in the inclined orbit. So inclined orbits will have 55 degree inclination at the equator. Of course, the geostationary orbit, they will have 0 degree inclination because they are in the equatorial plane in the designated slots, and these are having a time period of about 11 hours 57 minute for GPS, 11 hour 15 minute for GLONASS, 14 hours 4 minute for Galileo, and 12 hour 53 minutes for BEDO in the lower Earth, medium Earth orbits, whereas 24 hours for the geostationary orbits. So most of them are in the MEO and the highly elliptical orbits known as Molniya also in case of the Russian design. Besides that, it is also seen that the satellites are visible at any point of time from more than one ground station. So that is also one way it has been designed. So there are interesting nomenclatures which has been used for the satellite based constellation based on the astronomical figures or the star combinations in the satellite. So the BEDO, which is referred in different civilizations as per their astronomical considerations. So Chinese BEDO is basically the name for the Big Dipper and the Saptarishis in the Indian context. Similar designs were there in the Indian and the Tibetan culture also. So Ursa Major is the third biggest constellation in terms of area after Virgo and Hydra, making it one of the most iconic marks in the night sky, and based on these names has been coined. Quasi-Zenith satellite system, it is called Mishibiki, which means again guide. So definitely the GNSS systems, GPS, GLONASS, Galileo, BEDO, QZSS and Navik, they are being used for the purpose of the guidance. So that is how the GPS and the satellite based navigation has been developed over time from different surveying era, we can say, from traditional surveying to tower based navigation to the satellite based navigation. So satellite has been a space component which we have to understand. So there was a block 1. So these are different type of, we can call them different generations of satellites. So block 1 generation satellites, they were launched between 1978 to 1985. None of them is in service now. There were 11 in numbers. They were followed by block 2 and block 2A satellites, which were 27 in numbers, and they were launched between 1989 to 1997. They were followed by GPS satellites block 2R and 2RM with addition of some new codes like L2C and military code M, followed by block 2F, which was having an additional carrier frequency besides the L1, L2, it was having L5 also, and currently block 3 is under delivery or design. So in that, 6 satellites are already operational, and these different nomenclatures are based on the different developments which has taken place. So the electronics has been more and more light, more and more efficient, with lesser power consumption requirements. So weight of the satellites has been reducing, whereas the life of the satellites has been increasing. So that is how the different set of satellites has been provided nomenclature: block 1, block 2, block 2A, block 2R, block 2RM, block 2F, and block 3. Block 3 has also been divided into block 3A and block 3F. Now, currently, the biggest threat is the cyber security threat. So, considering that there is a new design which is going on for the block 3F, under which 6 satellites has already started operation. The major difference is that under this block 3, what is happening, the entire ground segment is also being replaced. Entire hardware on the ground need a replacement along with the new software, and it is costing about $500 million for the software alone, and $6 billion for the entire replacement of the GPS. So the future GPS, we will see that block 1, block 2 series, 2, 2A, 2R, 2RM, and 2F, they all will be completing their lives, and we will be depending on the block 3. Block 3 has capability of providing 3 times more accuracy and 8 times improved anti-jamming capabilities. Now, these are the satellite signals which US is looking for their future civilian as well as defense requirements. So block 3 satellites, they are provided with the M code and providing higher accuracy for the military aircrafts like F-22 and Hawkeye, which safeguard them from the jamming and other spoofing operations. So that is how this development is going on for the space segment and the ground segment for the GPS. So today we will stop here, and we'll take up the questions in some time, maybe a break of 2-3 minutes,